Hey, sixth grade. Continuing on volume today, but we're going to come up with a formula for volume, if you haven't already, to kind of like speed up the process. So make this the title of the next free page in your math notebook. When you have done that, unpause and close up your notebook until we get to the we do. So a couple quick connects. Let's start with formulas. So you remember, formulas are not the only way to calculate something in geometry, but they are often the fastest way. You know, when we talked about like finding the area of this triangle, for instance, we had a couple strategies. The first one was called doubling, where we would like make it into a rectangle, then find the area of the rectangle, and then say, oh, well, then that must mean each of these is half of that. But a formula kind of sped that up. When we did that enough times, we figured out we could kind of speed up the process by just saying the area is going to be the base times the height times a half. And we could do that to just go faster than always applying this longer method. We basically turned what we figured out here into a formula so we could do future problems faster. And that's what we're going to do with volume today. So when it comes to volume, we learned yesterday, that to find the volume of this, we're really asking the question like, how many 1 unit cubes can this hold, or can pack into this? And yesterday we kind of actually did it with physical cubes. So if I imagine filling this up with cubes, there's going to be 3 rows of them, because it has a measurement of 3 that way. And there's going to be 4 columns of them. So this is what it would look like if they were like flat. And then they're going to go too high. So they're going to kind of come up to here, halfway. And these get really kind of tough to draw. I can kind of do it. You can imagine how they're going to look, but it gets really difficult to draw these, right? So, rather than trying to figure out how to draw all those in, it would be nice if I could come up with a formula. So I'm just going to think of it that way. I'm going to have, there would be cubes on the bottom, and they would be about this tall. They would go halfway up since there's 2. So there would be a layer on the bottom, and then a second layer of those would kind of start halfway up. I should do a dotted line in the back. And then there'd be another layer on top. And that's what I would do. So I would count all these cubes that I had to fit in there. But it would not be easy to kind of do this all the time. And it would certainly not be easy to do this if we started making these numbers a lot greater like this. Then it starts to get really obnoxious to try to use the cube packing strategy. So it would be nice if we could take what we learned yesterday about volume and use that to create a formula that we could use reliably to do these a lot quicker. So that's what I want to do today. I'm going to take this same one, and I'm going to talk about doing that now. I'm actually going to go back here and do the I do on this, since I did such a nice job. So here's what I want you to think about. When you do a volume question like this, think of it this way. Even though you can't see the cubes down there, this is how many there would be, right? This would be like the bottom of all the cubes, and there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cubes on the bottom. And then there would be, so there'd be like 12 in the first layer, and then there'd be like 12 in the second layer. And altogether the volume would be 24 cubic units. That's what it's going to end up being. So if I go back kind of a bit and kind of take these away, here's what I want you to notice. If you notice, when I drew the bottom of the tiles here, I really just tiled the bottom like in area. If I was just finding the area of the bottom and the whole rest of this thing was not even there, if I can do that fast enough, if all this was kind of gone and I just had that rectangle at the bottom, I really just found the area of the bottom as though that were a rectangle. And so if I put the rest of it back, so this 12 I found at the bottom is really the, I'm going to call that, I found the area of the base of the figure, if you can see that. So I took the area of the base, and which was 12, and I multiplied it by the number of layers. Right, there's going to be 12 on the bottom, and then we're going to go up to the second layer, and there's going to be, I'm going to multiply this by 2 because there are 2 layers. If this were 3, which it's not, then instead of having 2 layers of 12, I would have 3 layers of 12, so I would have 12 times 3. So all we really have to do is see like how many cubes fit along the bottom. That's called, we're going to call it the area of the base. And then how many layers of that are there? We're going to call that the height of the cube. And so if I make all this go away, so I can easily make a formula, that's going to be the formula we use. So the formula in words is the area of the base times the height, or the number of layers that we have here. So 4 times 3 is 12, times the height is 2, and so I would get a volume of 24. In the way mathematical type people show that with symbols is they make the area of the base be a capital B, area of the base. That's actually, they do big B because it's not like, lowercase b would be like just the base of like a 2D figure. So big B is like the base of a 3D figure times the height. And so that's our volume formula. Volume is the big base times the height. So in that case, to use that, the big base is the area of the base. That is 4 times 3. And the height is 2. 4 times 3 is 12, times 2 equals 24 cubic units. Okay. Open up your notebook. We're actually going to do 2 we do's, a slow we do and a fast we do. So let's start with the slow we do. I want to have you go ahead and pause and draw this. And then after you've done that, unpause. And this one we're going to come up with the formula. And then the next one we're just going to apply it. So if we do this with the kind of the packing strategy, I want you to actually go through the pain of drawing these in, because that'll make you appreciate the formula more. So there'd be like 3 along the bottom, 4 along the side. So if I use the packing strategy, 12 fit on the bottom, right? And then there would be 5, I'm going to put it on the other side so it all fits together. And then there would be 5 layers. So the volume would end up being 12, the 12 from the bottom times the 5 layers equals 60 cubic centimeters. That's with the old packing strategy, right? What I want to really come up with today is how we use that to come up with a formula. So the formula is this. Formula is the area of the base times the height. So that makes sense, right? We tiled the bottom, and that gave us the area of the base. The area of the base is 12, and we would have one layer of cubes, of 12 cubes in the bottom, and this is how many layers we would have. We would have 5. So in mathematical terms, we would say volume equals big B for area of the base. Make sure you know what the big B is, times the height. All right, and when we apply this formula, we just do what we did over here, right? The big B is the area of the base, and since that's a rectangle, that's 4 times 3, and the height is 5. 4 times 3 is 12. Times 5 is 60 cubic centimeters. I'll do the other unit method that way. Okay? So that's how you do it. That's how you come up with the formula. I don't like to just give you a formula to memorize, because then there start to be a lot of them, and it's like, well, where did this come from? Why does this work? Where do all these numbers come from? I like you to know where they come from. But the reason I want you to have a formula is if you go to another we do, you can do a bottom half of your page or something like this. If we get to something like this, where there's just, I mean, it would just be really obnoxious to have to tile this or pack this with cube. If I say, you know, I want to use the packing strategy, like you could, I don't want you to think you couldn't, but it's somewhat long and annoying, I'm just going to say. And so it's nice to have a formula. If you understand why the formula works, it's nice to have a formula that allows you to do this quickly. So again, the formula for a rectangular prism, the volume equals the area of the base, times the height, and the height is like the number of layers. So in this case, the base is a rectangle, a 20 by 9 rectangle. So the area of rectangles is just calculated by their length times their width. So the area of the base is 20 times 9 times the height is 8. So that means there would be 20 times 9 is, 20 times 10 is 200, so 20 times 9 is 20 less. So 180 would fit on the bottom. Just so you can see where this would come from. There'd be 180 cubes on the bottom layer, and there would be 8 layers to fill it up. So 180 times 8, I don't have a calculator handy. 180 times 8, 0. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. So it would fit 1,440 cubic centimeters. And, you know, that's nice. This would be a real pain to draw, 1,440 of these. So the formula is nice when you run into situations where it would just take a really long time, be long and annoying, or not even possible to do the packing strategy. But I only like you to use formulas if you understand where they came from and why they work. Alright, so that's it. That's how you apply a formula to find the volume of rectangular prisms. Notice we only applied this to rectangular prisms today. I don't want you to think necessarily this is like any kind of figure you could ever find, but this does work for rectangular prisms. Once you feel like you have a handle on this, if you need to go back, watch again. If you feel ready for class tomorrow to do a great job, you're all set. Can't wait to see you then.